Love that. So, every single tissue in the human body, every single cell can be categorized broadly into four different types. You've probably heard me say this like a million times by now, but it is so fascinating that anything in the human body, four different types. What do we think they are? You're gonna have epithelium, you're gonna have connective tissue, muscle, and nervous tissue. We've already gone through three of these. We know what muscle tissue is, we know what epithelia are, we know what connective tissue is. So, when we're thinking about epithelial tissue, what do you think they're gonna do? Like, if you want to broadly categorize all of them as having a common function, what do we think they do? Yep, they're gonna cover surfaces. They're gonna line body surfaces and cavities, and they're gonna secrete stuff, typically in glands. So they're gonna be made up of epithelial cells. There's gonna be super tight gap junctions, which means what are we not gonna find? Extracellular matrix. At least not a lot of it. Your connective tissues are going to have a lot of ECM, extracellular matrix, which is essentially just ground substance and fibers. We just like having names. We like naming things. You figured it out by now. Um, but yeah, your epithelial tissue, it's going to be made up of these cells and a basement membrane. So what's the basement membrane? It's kind of like the double-sided tape that they're sitting on. So this double-sided tape, underneath it is going to be dense regular or dense irregular connective tissue, depending on where in the body we're looking at. And on top of it, you're going to have epithelial cells. You can have either one layer of epithelial cells or a whole bunch of them stacked on top of each other. Simple, stratified. It's kind of like a single tissue paper versus like 40 papers like sitting on top of each other. You're going to add some strength. Um, if you want to think about shape, you have three different shapes: flat, squamous, cuboidal are boxes, columnar, they're pillars. Um, Mush all of them together. Wow, six different types. You only need to know four of them. Simple squamous, simple cuboidal, simple columnar, and stratified squamous. So here's examples of these tissues in like actual pictures and not drawings. Um, but yeah, As as always, there's always more. Yay. So there's this interesting type of tissue called the pseudostratified columnar epithelium. What does pseudo mean? Fake. Love that. It's fake. It's pretending to be stratified. It's not. Um, how do we know? Do we see how all of these cells are attached to the basement membrane? So all of these cells are attached to the basement membrane, which means there's no layering going on. All of them, they're on the basement membrane. Um, so how would we differentiate this from, say, stratified tissue? Well, your stratified tissue, do we see how all of their nuclei are in a straight line, kind of like sets? Your pseudostratified columnar epithelium, it's going to be wonky. It's going to look wonky. You're going to see nuclei at multiple different levels. You're also going to see specializations. There's two of them. You can have either goblet cells or cilia, sometimes both. So goblet cells, they're these unicellular glands that are going to be making mucus. Well, actually, they don't make mucus. What do they make? Mucin. And when mucin touches water, it gets sticky. Yay. In your cilia, they're kind of like these hair-like projections on the apical surface, and they're going to be beating in one direction away from the lungs. So let's think about this. There's a foreign body in your airway, and it's kind of wet. Um, what's it going to do? It's going to activate the mucin. The mucin's going to trap it all together, make it sticky, and help the cilia move it away. So do we see how they're kind of like working together with each other? Yay, the power of friendship and whatnot. You're also gonna have transitional epithelium. It's gonna transition from one shape, kind of like bubbly, to another. It's gonna stretch. How do we know that this is in cuboidal? Well, do we see how there's kind of like these umbrella shaped domes on top? That's going to be the part that stretches. And towards the middle, you're going to have kind of like these trapezoidal shapes. So again, where do we think we're going to find these? Places that need a lot of stretch. Yep, the only place you're going to find this in the human body is the urinary tract and the lower reproductive tract, but they're kind of developmentally similar. So the only place, ureters. Yay, anatomy. Okay, all good so far? Bien, beautiful. Okay, so what do connective tissues do? A lot of things. Yeah, they're gonna do pretty much everything that's on the slide over there. Read it at your own time. Um, You're going to have four different categories of connective tissues. You're going to have connective tissue proper, cartilage, bone, and blood. So when you're thinking about connective tissue proper, these are the cells that actually have the ECM fibers, specialized cells, the whole textbook shebang. So you can either have loose connective tissue proper or dense. And this is just how they're packed, how the fibers are arranged. Um, when you're thinking about loose, do we think they're gonna have more ECM or less? More, yeah, because they're loose. There's gonna be less fibers and more ECM. So you're gonna have areolar, adipose, and reticular. And each of these, they're telling you what fibers they have. Areolar, they're gonna have a lot of collagen fibers. Um, these are kind of like packing peanuts. They're gonna stuff spaces in your body that aren't filled just to offer cushioning and protection. Yes. I think it's supposed to be like mast, like on a ship. Yep. Like the mast of a ship. It's like anchor, areolus. Yep. So it's the anchoring tissue. Your adipose tissue, think adiposity, fat. So this is gonna be some reticular fibers that are holding together fat cells. So fat cells, they don't really like to take in stain because they're lipids and lipids don't like water. So you're going to see all of these seemingly blank spaces where the fat cells are. You can still see these reticular fibers that are like holding them together. So yeah, that's how we know it's tissue. Reticular, that's just all reticular fibers. Think reticular, meaning net-like. So it's kind of like a fish net. It's going to trap different kinds of cells and keep them in place. So when we think about lymph nodes, you're going to see reticular tissues because we want all of our white blood cells in one place, just sitting there. Yay. This is exactly what it was going on about. And yeah, so if you want to think about it this way, packing peanuts, insulation, and wire mesh. Yay. Your dense connective tissue, you're just going to have two types, regular and irregular. Dense, regular, all of your fibers are going the same direction. So you're going to get stretch resistance in one direction. Dense, irregular, you're going to have mosaic, which is basically multi-directional resistance. Yay. So yeah, if you want to summarize all of your connective tissue, this is what they're going to look like. Um, this is important. This is going to be important if you want to understand kind of like how they're characterized, categorized. And as always, all these slides are up on Canvas if you want to access them. Um, yeah. Did that answer your question? Love that. Yay. Thank you. For sure. So when you're thinking about stress resistance, think tendons and ligaments. So over there, you're only going to be moving in one direction. Your tendons at the end of your muscles, one direction. So you're just going to need unidirectional stress resistance. So you're going to have dense regular. Dense irregular, think about places that need to come back to its shape kind of like all the time. So your skin, we're gonna go over this on Friday, which is tomorrow. Yep. The top layer of your skin is epidermis, which is gonna be What type of tissue? What do we think? Epidermis? Epithelium. Beautiful. Yay. So you're going to have stratified squamous epithelium on the epidermis. Right below the epidermis, the part that's actually connective tissue, that's going to be dense, irregular connective tissue. You're going to need that multi-directional stretch resistance. The dermis. Look at you go. Yay. You're learning. Love that. Okay. Do we have any more questions or do we want to do a Kahoot? Yes. That is a great question. And I'm going to say for each lecture that you had, you're going to get about 8 questions from each lecture. So, yep, do with that what you will. Hey,